Lesson 1-2 is about solving equations by addition or subtraction. So just a couple of vocab to get out of the way. An equation, there's a difference between an equation and an expression. An equation is a mathematical statement that two expressions are equal. So for instance, 2x minus 5 is an expression, and 13 is also an expression. But let's say that we let both of these be equal to each other, and as soon as we put an equal sign in between them and say that the left side is exactly equal to the right side, we have what's called an equation. If we just had the 2x minus 5 and we didn't have any of this over here, including the equal sign, the 2x minus 5 is an expression. As soon as we set it equal to something, whether it's a number or another expression, you now have an equation. What is the solution to an equation? It is the value of the variable that makes the equation true. So we are going to find the solution, and sometimes there's more than one solution, but for our purposes in this section, you're only going to find one solution. So let's look at example 1. And here's the important part. You can do these in your head, some of them, and come out with the answer. It's not all about getting the correct answer. It's about showing your work correctly and checking. So if you don't show your work to both sides of the equation, you will miss half credit. It doesn't matter if you get the answer right. You have to be able to show your work. While if you can show your work to a one-step equation, it makes it so much easier when we move to two-step and multi-step equations. If you refuse to do it now, you're going to have to relearn when we get to more complicated equations. So what I want you to start to get in the habit of is drawing a line straight down from that equal sign. It's called your brick wall. Whatever you do to the left of this brick wall, you have to do to the right. And so I want you to isolate your variable. Right there. So we're going to take that x, and we have to get rid of this 10 because we want to get the x by itself. So we have to get rid of this 10, and we have to do the opposite of minus 10. So the opposite of subtracting 10 would be to add 10. So we're going to add 10 to both sides. Our focus is always on the side where the variable is. So I'm going to draw a line, and then I'm going to show that these cancel each other because a negative 10 and a positive 10 form that zero pair. And so we end up with an x on the left equals, don't move, that equal sign should never ever move, and then a 14 on the right. And so you get x equals 14. Now you might have made a math error. Who knows? So you've got to check your answer. So what we're going to do is we're going to take this 14 and replace it back in for x. So when we check it, we're going to use the original equation. We're just going to replace x with the value that we came out of and see, do we have a correct solution. So we have 14 minus 10 equals 4. And then you're not going to add or subtract anything to both sides. You're going to work the left side separately from the right side. So this is the only side that we have to work. So 14 minus 10 is 4. Does 4 equal 4? Yes, indeed it does, so it checks. Look at example 2. Don't freak out with example 2. You see fractions, but if you notice, the fractions themselves have the same denominators. So when you have like denominators, you can add and subtract their numerators. So it doesn't matter what side of the equation the variable is on. Remember, the very first step is to draw that brick wall. Then I want you to circle your variable because we want to isolate that. That's where our focus is. Our focus is on the right side of this equation. We want to get rid of this minus 1/3. The opposite of subtracting 1/3 is to add 1/3. So what we do to one side, we must do to both sides. So we are going to add 1/3 to both sides. Make sure you show it to both the left and the right side. So on the right side, they cancel because those form a zero pair. We have our equal sign directly in the middle. Our m is on the right. On the left side, we have 1/3 plus 1/3. So when you have like denominators, you just add those numerators. So 1/3 plus another third means that I have 2/3. If it bothers you to write that backwards like that, you can flip it around, and then you could just say, oh, well, m equals 2/3. Either answer is acceptable. But you have to check your answer. So we're going to take the original equation here, exactly as it's written, and we're going to replace m with 2/3, our value. So for our check, I had 1/3 equals, instead of m, I'm putting in 2/3 and then minus 1/3. Work the left side of the equation separately from the right. We don't have anything to do on the left, so we have 1/3 equals. And then on the right, we've got like denominators, so I can just do 2 minus 1. 2 minus 1 is 1/3. 1/3 does indeed equal 1/3, so our solution checks. So that was using addition. Both of those are addition. So now we're going to move to using subtraction. So let's look at example 1 and 2 here. Same thing, you're going to put your brick wall in here. So drop your brick wall down. We want to isolate the variable, so circle that variable term. We want to get the x term on the left side by itself, so we need to get rid of a positive 5. The opposite of adding 5 is to subtract 5. Or in our case, the opposite of a positive 5 is a negative 5, because I want you to start to view this as being opposite operations. So instead of thinking that we're subtracting 5 from both sides, we're really adding a negative 5 to both sides. Make sure you show it to both sides. The 5 and the negative 5 cancel. That leaves us with an x on the left equals. And then technically you should view this as an addition statement here. I realize that 11 minus 5 is simple, it's 6, but I really want you to start to look at it as 11 plus a negative 5 and use those integer rules that we went over, and the answer is still positive 6. So then you're going to check your answer. Take the original problem right here, and instead of x, you're putting in the 6. So we have 6 plus 5 equals 11. Work the left side. 6 plus 5 is 11. Does 11 equal 11? Yes, indeed. So example 2 has decimals. Again, don't let the decimals freak you out. They're just decimals. So we're going to draw that brick wall straight down. I want you to isolate that variable. So we want to get the d by itself. And so we need to do the opposite of adding a 0.2, which is 2/10. So the opposite of a positive 0.2 would be a negative 0.2. So we are going to add a negative 2/10 to both sides. Draw your line, cancel out your 0 pair. So on the left, our decimals have to be lined up when you add or subtract decimals, so they're lined up. We just need to do 7 minus 2. So bring that down that decimal point. 7 minus 2 is 5. I'm going to put a 0 in front of the decimal so we can see the decimal. Equals, and on the right side, the only thing that's left is d. So the value for d is 5/10. Let's check to see if we got it correct. So take your original problem right here, and instead of d, we're replacing it with 5/10. So 7/10 is equal to 5/10 plus 2/10. So the left side, we didn't have anything to do. On the right side, if you take, a lot of you, I mean, clearly you're going to try to force this to work, but think of it this way. We're going to take 5/10 and add it to 2/10. So a lot of times it's easier just to add and subtract your decimals vertically rather than horizontally this way. So I'm just going to add straight down. I've got the decimals lined up. I'm going to add straight down, and sure enough, indeed, it does come out to be 7/10. So it checks. Let's look at the next page. So example 3, again, draw your brick wall. Isolate your variable. What variable do you want to get by itself? We want to get the plus b by itself. So this time, you've got a negative 7. The opposite of a negative 7 is a positive 7. That's what makes a 0 pair with it. So we have a positive 7 here. What we do to one side, we have to do to the other side. And draw your line and cancel out your 0 pair. On the left, you've got a positive b equals. And on the right, we have 20. So let's check our solution. In our original problem, we have negative 7. Instead of b, that's a plus. Instead of b, I'm putting in a positive 20. And I want to see, does that equal 13? So based upon our integer rules from last week, different signs subtract and take the sign of the larger. So we're going to do 20 minus 7 is 13. Because 20 is larger, it is a positive 13. So indeed, 13 does equal 13. Don't force the check. Make sure it actually works. So let's look at a fitness application. If you were in my classroom, I'd have you do this with your partner next to you. A person's maximum heart rate is the highest rate in beats per minute that the person's heart should reach. One method to estimate maximum heart rate states that your age, so this is important, states that your age added to your maximum heart rate is 220. So the part that's going to change all the time is your age. I'm sorry, not your age. It's going to be your maximum heart rate. So depending upon your age, every age has a different maximum heart rate. So at the age of 14, your maximum heart rate might be, I don't know, at 500 beats per minute. Whereas at my ripe old age of 40 something, my maximum heart rate that I should reach might be, 220. So it just depends upon your age. So it asks you to use this method, write and solve an equation. We have to know what we're finding. So we are to find the maximum heart rate. So that's what we don't know of a 15-year-old. So the things that we do know is this: the age of the person, is equal to 15 years. And then the other thing that we know from the information of the problem is that what we don't know is your maximum heart rate. That we don't know because that's what we're trying to find. But to find it, you take your age and add to your maximum heart rate is 220. So whatever it is, it should add up to 220. So we're going to let X, our unknown, be our maximum heart rate. Okay, so if we're working with a 15-year-old, if we took 15 and followed what they said here, your age added to your maximum heart rate. Well, we don't know our maximum heart rate, so we're going to take our age and add our maximum heart rate to that. It should be is. Is always another word for equals. So immediately I know I'm going to put an equals right where that is. So we're going to put an equals here, and it should equal 220. I'm telling you, this isn't quite realistic, but we'll go with this situation. All right, so we've converted this whole word problem into an equation. And once again, that equation is a 15-year-old person plus their maximum heart rate should not go higher than 220. So clearly, the older the person, the lower their maximum heart rate. The younger the person, the higher that maximum heart rate is going to be, but everybody should attain that number of 220. So we're going to solve for X and see what the maximum heart rate for a 15-year-old would be. So draw the line all the way down. We want to isolate the variable positive X. That means that we need to get rid of this 15, and there's no sign in front of it, so it's understood that that 15 is a positive 15. So the opposite of a positive 15 is a negative 15. So we're going to add a negative 15 to both sides. We're going to cancel out our zero pairs. We're left with an X on the left. And then technically we are taking a 220 and we're adding a negative 15 to that. I want you to start to think of everything in terms of addition. We no longer subtract theoretically in algebra. So we're really adding two numbers with different signs. So different signs subtract and keep the sign of the larger. So 220 minus 15 is 205. And the 220 is bigger, so our 205 is going to be positive. So our solution is 205. Make sure that you answer the question. The question says, Using this method, write and solve an equation to find the maximum heart rate. So therefore, the maximum heart rate for a 15-year-old is 205 beats per minute. I think that's the bottom of this page. Yeah, so let's look at Then again, this is your turn. So these are some example problems that we're going to do in class. Most of these are even problems. So if you're doing them in class, I will give you the answers. If you're doing them at home, you can come check your answers with me before school. But this is going to end up being your homework for today. If you're in an honors class, I probably have added to that assignment. So look at your calendar.